Alrighty, let's go ahead and get started on the next video. Now, we're just going to run through some examples. Some of them that can be done more than one way. This is one that can be done more than one way. Now, we've seen ones like this before, okay? And this actually can be done as straightforward u sub. So if I have u, 9 minus x squared, and I know that du is going to be negative 2x dx, I can actually solve for that remaining x squared by doing 9 minus u. And so what I would need to do is say, well, that's x squared, 9 minus x squared, negative 2x dx, and of course that negative 2 that I've introduced requires me to put a negative 1/2 out in front. And now it becomes very, very simple in terms of substitution. That's negative 1/2. The x squared is 9 minus u. Now I could take that negative right there and flip that difference, but it really doesn't matter. Minus du, and that becomes negative 1/2 9u to the 1/2 minus u to the 3/2 du. And you can go ahead and integrate from there. That becomes negative 1/2. This becomes 9 times 2/3 u to the 3/2, 2/5 u to the 5/2 plus c. Okay, now when I distribute this negative 1/2 across, the 1/2 cancels with this 2 and that 2. I just have to make sure I remember to distribute the negative. That's negative 3 u to the 3/2 plus 1/5 u to the 5/2 plus c. And then when you substitute back in, you get 9 minus x squared to the 3/2 plus 1/5 9 minus x squared to the 5/2 plus c. But let's pretend we didn't see it. And you can actually do this exact same problem just by doing, this was complicated enough, and actually the trig sub doesn't wind up being all that many more steps, but I know that this is a squared minus x squared, and I know that my x squared needs to be 9 sine squared theta, which means that my x is going to have to be 3 sine theta. Okay? Well, if that's the case, then x cubed is 27 sine cubed theta, and dx is 3 cosine theta. Now, that's all I really need for right now. And so let's go ahead and plug it in. So the x cubed becomes 27 sine cubed theta. Underneath the radical, I get 9 minus 9 sine squared theta. And then for dx, sorry, that needs a d theta on the end, I'm going to get 3 cosine theta d theta. Now that 9 minus 9 sine squared theta becomes 3 cosine theta after it's simplified, right? And so I'm going to take 3 times 27, which is of course 3 to the 5th, and that winds up being 243. I'm going to go ahead and simplify that integrand by combining like factors, and now I have something that is very, very similar to ones that I saw in the last section in the when we were doing trigonometric integrals. I need to go ahead and change one of the sine squareds right here, or two of the sines. I'm going to reorder this a little bit. I'm going to put my cosine squared first. Then I'm going to put 1 minus cosine squared, being one of those, okay? Then I'm going to put the sine theta that's left over next to here. Now, I don't like to put negatives out in front if I don't have to, so whereas I'm going to put a negative right here, I'm going to use that. Instead of putting a negative out in front, I'm just going to flip the difference. So that's, it's just a way that I like to do it. I don't want to introduce any more negatives than I really have to. And so I have 243, the integral of cosine to the 4th theta minus cosine squared theta. And of course, if I were to actually do the u substitution, which is really, really plain in here right on the face of the problem, that of course would be my du. I'm going to have 243 This becomes 1/5 cosine to the 5th theta. This becomes 1/3 cosine cubed theta plus c. Now this looks really, really complicated, but up to here, I mean, the integration hasn't really been all that bad. Let's go ahead and flip this around a little bit. That's going to be sine theta is equal to x over 3. Let's go ahead and draw that triangle, x, 3, and this right here winds up being 9 minus x squared. Is anybody surprised? I hope not. Okay, so 243, and this is going to be 1/5. Now, what's the cosine of that theta? Well, cosine of that theta is going to be adjacent over hypotenuse, 9 minus x squared, all of that over 3 to the 5th. And then I'm going to have cosine cubed, 9 minus x squared over 3 cubed plus c. Now this is all going to clean up rather nicely, because the moment that I distribute this, the moment I distribute the 243, let's go ahead and do that. This winds up being 243 over 5. This winds up being 243 over 3. Okay. Well, when I raise this to the 5th, I recognize the denominator is going to be 243. 243, 243, they cancel out, and what I'm going to get is 1/5, 9 minus x squared to the 5 halves. And what I'm going to get here is this already reduces, by the way, to 81. 81 is going to be divided by 3 to the 3rd, which is 27. And so that winds up being 9 minus x squared to the 3 halves plus c. And if you notice, it took a few extra steps, but that answer is identical to the one that I have right here. Just the terms are in a different order. Okay? This one can be done by either u sub, using what I've referred to in the past as back substituting, right? You have to make sure that you see the fact that solving for x squared and then basically parsing it out like this becomes necessary, or with a few extra steps, and those of you who are uncomfortable with trig won't really like it all that much, you still get an identical answer right like this, okay? Now, let's go ahead and move on to the next one. I'm not sure whether this one can be done in more than one way, and in fact, this one I'm really not caring because it would require a whole lot of finagling if it were to be done in another way. dz over z cubed, and that becomes z squared minus 4. Now, is this sine, is this tangent, or is this secant? Well, this is going to be secant, and I'm going to need z squared to be equal to 4 secant squared theta, so z is obviously 2 secant theta. All right. Well, that means that z cubed is 8 secant cubed theta. dz is equal to 2 secant theta tangent theta d theta. And I think that's actually all I need right now just to do my substitution. Of course, I'll need a little bit more here in just a second. Let's go ahead and do the dz in that numerator. Okay, so there's my dz. My z cubed winds up being 8 secant cubed theta. And then, of course, I need to substitute into the radicand. So 4 secant squared theta minus 4. This right here winds up being 2 tangent theta, which, of course, cancels with that 2 and with that tangent theta. So if I'm going to cancel those out, that one goes away as well. That 1/8 I'm going to pull out in front, okay? But before I do, I'm going to go ahead and actually get rid of that secant in the numerator and change that from being cubed to being squared. And this cleans up rather nicely. I wind up getting secant squared in the denominator, or cosine squared theta d theta. if I remember my power reducing formula for cosine, which I should, okay, the cosine one winds up being 1 minus cosine 2 theta over 2. Okay. 1 minus cosine 2 theta over 2. Well, the over 2 comes out here and winds up getting combined with the 1/8. And when I split it up, that winds up being 1/16 d theta minus 1 over 32, and it's 1 over 32 because I'm going to need to introduce this 2 in here in order to set up the u sub. This winds up being 1/16 minus 1, or theta, 1/32 sine 2 theta. And we've seen one like this before. It wound up being a good idea to go ahead and transform this into sine theta cosine theta by identity, because I know that secant theta is z over 2. The easiest way to wind up doing this is just to go ahead and construct the triangle. Secant is the reciprocal of cosine, and therefore it's hypotenuse over adjacent. And this, of course, winds up being z squared minus 4. I hope nobody is surprised about that. 1/16, well, theta, if there's nothing to actually, no trig function, it's just theta by itself, is arcsecant z over 2. This winds up being 1/16. Now, sine of theta is opposite over adjacent, so you wind up with z squared minus 4 over 2. Cosine is it should have been, opposite over hypotenuse, and now it's adjacent over hypotenuse plus c. Well, that simplifies rather easily into 1/16 arcsecant. Let me scoot that up just a little bit for you. Z over 2 minus 1/8 z squared minus 4 over z squared plus c. Now that is a little bit ugly, but doable, okay? Very, very doable. There's nothing in that particular problem that you should be unfamiliar with, okay? Let's see. I think we have time for one more. Let's go ahead and do one more. Okay. Okay. The integral of dx over x squared plus 1 cubed. Now, it's a sum, so obviously x squared is going to be tangent squared theta. So x is just tangent theta. Dx is secant squared theta d theta. And I think right there I have everything that I need at the present moment in order to go ahead and substitute. This winds up being tangent squared theta plus 1 cubed. Okay, tangent squared theta plus 1 becomes secant squared theta. So this winds up becoming secant squared theta d theta over secant to the 6th theta. Okay, well that just becomes cosine to the 4th theta d theta. And of course, if I remember, and actually I think I may have gotten this mixed up last time in the last example, but the cosine, yeah, I think I did. The cosine is the sum, right? And so you wind up with 1 plus cosine 2 theta over 2 squared, because it's cosine squared squared. That winds up giving you a 1/4 out in front, and cosine squared 2 theta, so I'm going to have to do it again for that term, 2 theta plus 1 d theta. Okay, so that becomes 1/4 the integral of cosine squared 2 theta d theta plus 1/2 cosine 2 theta d theta. And actually, I could have just kept that 2 with the d theta in order to anticipate the u sub, but, you know, neither here nor there. Well, okay, let's go ahead and say, well, that's 1/8, 1 plus cosine 4 theta plus 1/4 cosine 2 theta 2 d theta plus 1/4 d theta. Once I rearrange things a little bit, that becomes 1/32 cosine 4 theta 4 d theta plus 1/4 cosine 2 theta 2 d theta plus 3/8 d theta. And I choose to integrate all in one step, so I wasn't gonna get ahead of myself. This winds up being 1/32 sine 4 theta plus 1/4 sine 2 theta plus 3/8 theta plus c. Now, I'm not gonna, because it would be burdensome to go ahead and change this back into x. You would need to. This is not your final answer. I would need to do the double angle twice with this to get it down to where I needed it to be, construct the triangle, and do all sorts of jazz like that. I would only have to do the double angle identity once here, and then here I would just, you know, it winds up being arctan x. So that brings us to the end of that particular video. We'll have a couple more examples in the third video, and then we'll move on to the next section. Bye.